In this section, we'll see an application of the dot product. One such application is the work done by a force. So sometimes we have a force that is directed along the line of motion, moving an object through a distance d, then the work can be found by taking the product of the force times the distance. But if we have a force that is pointing to a different direction, then the work done by the force is given by the dot product between the force vector and the displacement vector. And based on the definition of the dot product, that is equal to the product between the magnitude of the force times the magnitude of the displacement times the cosine of the angle theta that is formed between the force and the displacement vectors. Now let's see an application about that. Suppose that we have a sled that is pulled along a level path through the snow by a rope, and we have a 30-pound force that acts at an angle of 40 degrees above the horizontal and moves the sled by 80 feet. We're asked to find the work done by the force. So in this case, here is the snow path, and then we have here the sled, and we have force that acts at an angle of 40 degrees to the horizontal, and then the magnitude of the force is equal to 30 pounds, and the sled is displaced by 80 feet. And in this case, the work done by the force will be equal to the dot product between the force vector and the displacement vector, and that is equal to the magnitude of the force vector times the magnitude of the displacement vector times the cosine of the angle theta, and that is equal to magnitude of the force vector is equal to 30 pounds times the magnitude of the displacement vector, which is equal to 80 feet, and then times the cosine of the angle theta, which is equal to 40. And if we do the calculations here, this is approximately equal to 1839, and this is in foot-pounds. So the work done by the force is equal to 1,839 foot-pounds. Now let's see a different application. We're asked to find the work done by the force vector that is equal to 8 times the vector I minus 6 times the vector j plus 9 times the vector k that moves an object from the point P with coordinates 0, 10, 8 to the point Q with coordinates 6, 12, 20 along a straight line. The distance is measured in meters and the force is measured in newtons. So in this case, first of all, we'll need to find the displacement vector. So the displacement vector is the vector that moves from the point P to the point Q. So we have the vector PQ that is equal. So the displacement vector will have components, the difference of the x components of the x coordinates of P and Q. So we have 6 minus 0. And the difference as y component, the difference of the y coordinates of P and Q. So we have 12 minus 10. And as z component, it has as component the difference of the x of the z coordinates of the points P and Q. So essentially, this is equal to 20 minus 8. So the vector PQ, the displacement vector, will be equal to 6, 2, and 12. And therefore, the work done by the force field is equal to the dot product between the force vector and the displacement vector. So force vector dotted with the displacement vector PQ, and that is equal, the force vector has components 8, -6, and 9 from here. dotted with PQ, which has components 6, 2, and 12. So that is equal to 8 times 6, which is equal to 48, plus negative 6 times 2, which gives us a negative 12, and then plus 9 times 12, which is equal to plus 108, and therefore this is equal to 144. And then we have newtons times meters, which is equal to joules. So we have 144 joules, which is the work done by the given force vector.